Hey everyone, welcome back to the channel. In today's video, we're going to be introducing the logarithmic function. This will be a multi-part series relating to all things that involve logarithms, logs, and solving logarithmic functions. If you guys like this content, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. By the end of this video, you'll understand the properties of a log function, where it comes from, as well as how to graph it. So let's get started. So the main message I want to get across to you in this video is that a logarithmic function is really just an exponential function. In fact, it's the inverse of an exponential function. So here, if we look at a normal exponential function, we'd have y to some base a to the power of x. Now, the logarithmic function is actually just the inverse of that. So as an example, when we're trying to find the inverse of a function, so what we're going to do is we would have y is equal to a to the power of x, and then to find the inverse of it, what we're going to do is flip the x and y variables, and then solve for the new y variable. So this is going to be x is equal to a to the power of y, and it turns out that the logarithmic function is just writing this in a different way. So just writing this as log base a x is equal to y. This is how we isolate for y, is we take the logarithmic of it. And that would give us our logarithmic function, which is the same over here. So now if you were to look at it using an example, if we were to take the exponential function y is equal to 2 to the power of x, so here instead of a, we're doing base 2 to the power of x. Now, to get the logarithmic form of that, it would be y is equal to log of x base 2. And this is something I really want to point out. When you're looking at a logarithm, especially when you're first introduced to it, you shouldn't say log 2x or log x base 2. What you should say is, to what power must I raise 2 to get x? And that would be the y value. So again, we're kind of, since it is an exponential function, what we're saying is we're rewriting this to be, like we're saying it exactly like we would say this. To what power of must I raise 2 to get this value x here? So if we were to do an example and not a function, say I had log base 2 of 4. You would say, okay, what exponent value to the power of 2, so 2 to the power of this exponent value would get us 4, and that would be 2. And again, you could do this in a different way. You could say log base 3 of 27. So now 3 to the power of what will get us 27? So that's a lot easier way to remember it. So 3 times 3 would be 9, times 3 again is 27. So 3 to the power of 3 is 27, and that's what we could rewrite this here. These are similar or identical expressions here. Now I mentioned the fact that the logarithmic function is just the inverse of the exponential function. And so when we're trying to find the inverse of a function, we could, like I did before, we could instead have y to the power of a to x, and then flip the x and y variables, and then solve for y. And we found out that y is now equal to log of x base a. So that is the different way of writing this expression right here. And that would be the inverse. The other way we can do an inverse is, and we're doing the same kind of thing, we're just doing it with a different means. So here we have a table of values. And the way to get the inverse of this function is just to flip the x and y variables. So here, wherever I see negative 2, that's going to be the new y variable. So that's going to be negative 2 here, and then it's going to be 1 over 4. And if I keep writing this whole thing down, I'm just going to take what's all in this y column and put it in this x column here. So this will be now 1, this will be 2, 4, and 8. And now in the new y column, which is this x column over here, we're going to have negative 2, negative 1, 0. I should line these up a bit better. This is negative 1, 0, 1, 2, and 3. And that would be a way to represent it using a table of values to get the logarithmic function. And this process of either solving for x and y kind of algebraically, so flipping where the x and y are in the expression, that can be used for any function. You can use that for x squared. So if we had y is equal to x squared, the inverse of this function would be x is equal to y squared. Solve for y, y is going to be plus or minus the square root of x. And that would be the inverse of this function here. So we can always do that. We can always flip the x and y variables in the algebraic expression, or we could look at the table of values and switch the x and y coordinates there. That would also give us the inverse. And finally, there's one more. So here, what I'm going to look at is we have this logarithmic function of base 2, or sorry, an exponential function of base 2, so that's this red line here. And now I'm going to replot this value here, this new graph, the inverse of this exponential function 2 to the power of x. So now I'm going to look at, well, we have negative 2, 1/4. So we have 1/4, that's what we'll call it right here, and that's going to be negative 2 right there. Then we go to 1/2, so a little bit further, and this is going to be negative 1. So we have this point right here. Then we have 1, 0, so let's say that's here. And then we have 2, 1, so that's like right here, and 4, 2, probably right here, and then 8, 3, that'll be kind of off the page over here. So now if I connect this line, what this new inverse of this exponential function, or the logarithmic function, is going to look like is something like this. And it's going to go on and on forever. And note that in this example, here we had a horizontal asymptote on this axis right here. And a horizontal asymptote is given by, like in this case, it would be y is equal to 0. That would be the equation of this horizontal asymptote. But now since we're switching them, we're switching the x and y variables, instead of a horizontal asymptote for the exponential function, for the logarithmic function, we're going to have a vertical asymptote. And that's here at the value of x is equal to 0. So you can see how even the vertical asymptotes, or the, I guess, horizontal to vertical asymptote, the values stay the same on an absolute basis, but the x and y change. So here this would be x is equal to the power of 0, or sorry, x is equal to 0, and then over here we have y is equal to 0. So these are flipped, like the variables x and y are flipped again because it's its inverse. So now I'm going to draw both of the exponential graph and the logarithmic graph, so the inverse of the exponential. So the exponential graph looks something like this and goes up like that. The logarithm graph looks something like this and goes up like that. So here, what actually happens, and again, this is kind of another way of saying the same thing, but we're actually flipping over the equation y is equal to x. So sometimes we reflect over x-axis, or sometimes we reflect over the y-axis. In this case, though, to get its inverse, we're reflecting over the line y is equal to x. So this blue line is in perfect reflection of this red line, and the reflection line is y is equal to x. Okay, so to review, what I want to kind of go over is things to know about this logarithmic function. And what we have here is that exponential functions have horizontal asymptotes. That is this line right here, this y is equal to 0 line. And then coincidentally, or based on the fact that it's an inverse, we have the log functions have vertical asymptotes. And that is this value right here. And lastly, possibly most important right here, is that a log function is equal to the inverse of an exponential function. That's very important. So whenever you see y is equal to log 2x, I want you to say, to what power must I raise 2 to get x? So to what power must I raise 2 to get this x? Because again, we could say 2 to the power of y is equal to x. These are the exact same things. It's just we don't want this y variable in the exponent. And to get the y variable down, we have to use a logarithm. We have to use log base 2. So I hope you guys got some value out of this video. This will be part 1 of a multi-part series related to logarithms and solving logarithmic functions. If you did get some value, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. Let me know down in the comments below what you guys want me to cover next. Thanks again, and I'll see you guys in the next video.